Hello guys, hope you are having a fantastic day. My name is Ajay Putsala. In this video, we are going to discuss about the reduction of the noise from the data using an Arduino board. In the last video, we have discussed about them using the raw data. If you haven't checked the video, please check the link in the description so that you have a better understanding about this video. In the last video, we have taken the raw data using filters. But in this video, we are going to take the data from the PPG sensor like directly. The filters we are going to use are moving average filter and derivative filter along with the 3-point center difference filter. Uh, why we are going to use them as the for reducing the noises. A moving average filter, we are using it as a low pass filter such that the number of samples taken for averaging, I mean the total number, if we are increasing the number of samples for moving average filter, the more the average will be taken. Now going into the code for the moving average filter, here we are taking the just forget about these two variables. We are just think about this float x, which are having 500 samples, not samples, and y. And for the we in the void subgroup, we have written serial begin is equal to 9600 hertz. And in the void loop, we have taken the variable I as a integer is equal to 0 and written as while, which is 500 less, um, such that the we are taking 500 samples such that the input is read as analog read A0 from the Arduino board, and we are setting the delay as 10 milliseconds, so that the Arduino board will send, I mean the PBG sensor will take data after every 10 seconds, such that the sampling frequency is 100 hertz. Now for the moving average filter, we have taken, sorry, in this for this we are determining the integer again is equal to 0 and I is equal to less than 500, such that the loop should be running. And for in the moving average filter, we should take that the moving average filter is works as a averaging of the previous values of the present value. I mean, if you take in the average of the last previous eight some values along with the present value to give the output. So we are taking the averaging as eight samples, and such that we get the moving average filter is equal to y. And by plotting the graph, we can see that this is the this is the original signal, such that this is the moving average center. Here we have observed that the clipping, this is due to the external excessive pressure on the PPG signal. So we have to delicately use the PPG signal such that these clips should not become. But we have acquired this kind of, so better use a good quality of the PPG signal to get a sharp curves. Here see that the high frequency components are reduced since it is a low pass filter. And now coming to the second part, which is a derivative filter we are going to use. uh, the derivative filter reduces emphasis, can help us to emphasize the slopes of the signal. For emphasizing the peaks only, we will first smoothen the signal with moving average filter. So we are going to do next is doing the moving average filter, and then we are applying the derivative filter. Sorry. Mm. In here, see that the derivative filter, we are just taking the subtraction of the present value and the previous value, so that here we are getting that this is the original signal, such that the high frequency components are and low frequency components there. After moving average filter, the high frequency components are decreased, and the after passing through the derivative filter, we are getting the emphasis. This the green layer is the derivative filter of the moving average filter of the original data. So next coming to the baseline drift components. Generally the baseline drift component is the signal returned due to the external disturbance measured by the sensor during its activity. In order to extract this component, we must apply very large frequency signal such that the different very large sampling of the frequency using a moving average filter. So we have taken 350 samples to simplify the moving average such that we are getting the baseline drift as the green signal here. When after the here the moving original signal is this one, and then this one the signal is the moving average filter of this one. After subtracting the drift line component, we can get the original signal, but we have to take I mean, when any signal is comprised of the noise plus information plus baseline drift. So we are taking the noise here, mainly the high frequency noises, but we didn't emphasize the low frequency. But there is no problem about that. For the baseline component, we are subtracting it, and we are getting this yellow component, which is the final PBG signal. Thank you for the watching the video. If you haven't clearly understand about the designs or anything, please check the my previous video and give it a like if you like the video, and subscribe to this channel. Thank you.